Are you seriously telling me that her father cleans our toilets? And now she thinks she can waltz in here and tell us how to do our jobs? The words cut through the morning air of Apex Engineering's main laboratory like a blade, spoken loud enough for everyone in the room to hear. Senior Engineer Bradley Morrison didn't bother lowering his voice as he gestured dismissively toward the young black woman, who had just entered the facility carrying a worn leather satchel and wearing clothes that clearly hadn't come from an expensive store. I mean, look at her, Bradley continued, his voice dripping with disdain as he addressed his colleague, James Fletcher. What is she, maybe 22? Probably never seen the inside of a real engineering lab before today. And now she's supposed to help us with the Meridian project? The same project that stumped our entire team for a decade. James shifted uncomfortably, glancing toward the woman who was still standing near the entrance, clearly having heard every word. Bradley, maybe we should. Should what? Pretend that nepotism and diversity quotas are going to solve our problems. Bradley's laugh was harsh and bitter. James, we have PhD engineers from MIT and Stanford who've been working on that engine for 10 years. We've burned through $12 million in research funding. We've consulted with the best automotive minds in the country. And management thinks the solution is going to come from some janitor's kid who probably learned about engines from YouTube videos. The young woman, Zara Johnson, stood perfectly still near the laboratory entrance, absorbing the verbal assault with a composure that would have impressed anyone paying attention to her reaction rather than participating in her humiliation. Her dark eyes remained steady, her shoulders straight, even as Bradley's words were clearly designed to make her turn around and leave. You know what this is really about, don't you? Bradley continued, now pacing in front of the massive engine that had been the bane of Apex Engineering's existence for the past decade. Corporate is tired of explaining to investors why we can't make this thing work. So they're bringing in some token hire so they can say they tried everything, including, he gestured mockingly in Zara's direction, thinking outside the box and embracing diverse perspectives. Dr. Patricia Chun, the project's technical director, finally intervened. Morrison, that's enough. Ms. Johnson is here at my personal invitation, and you will treat her with professional courtesy. Bradley turned his attention to Dr. Chun, his expression incredulous. Patricia, with all due respect, this is insane. We're talking about the Meridian prototype, the most advanced experimental engine ever designed. This isn't some undergraduate project where we can afford to waste time on feel-good experiments. Actually, Zara spoke for the first time, her voice calm and clear despite the hostility she had just endured. The Meridian prototype has been non-functional for exactly 3,847 days as of this morning. During that time, your team has replaced the fuel injection system 4 times, rebuilt the transmission twice, and completely redesigned the cooling system. Despite all of these efforts, the engine has never successfully completed a full operational cycle. The laboratory fell silent. Bradley stared at her in shock, not because she was wrong, but because she was precisely right about details that weren't common knowledge even within the company. How could you possibly know those specifics? James asked, his earlier discomfort now replaced by genuine curiosity. Zara set down her leather satchel and pulled out a thick folder filled with what appeared to be handwritten notes, technical drawings, and printed reports. Because I've been studying this engine since I was 12 years old. Every night when my father finished cleaning these laboratories, he would tell me about the conversations he overheard, the frustration he witnessed, the theories he heard discussed. He started bringing home the technical reports that were being thrown away, drafts, failed proposals, debugging logs that engineers considered obsolete. Bradley's face flushed red. So you've been stealing proprietary information for years? I've been learning, Zara replied evenly. Reading discarded documents that were headed for the shredder isn't stealing. It's studying. And during those 10 years, while your team focused on replacing components and redesigning systems, I've been developing a theory about why this engine has never worked. Dr. Chun stepped forward, her scientific curiosity overriding the social awkwardness of the situation. What kind of theory? Zara opened her folder and pulled out a hand-drawn schematic that was far more detailed and precise than anything a casual observer should have been able to create. The problem isn't with any individual component. The problem is that you've been treating the Meridian as a traditional internal combustion engine when it's actually something entirely different. That's ridiculous, Bradley scoffed. Of course, it's an internal combustion engine. We designed it. You designed the components, Zara corrected, but you never solved the fundamental thermodynamic equation that governs how those components interact under the specific conditions created by your hybrid fuel system. She spread several more documents on the nearest table, revealing calculations that filled dozens of pages. The Meridian uses a fuel blend that creates plasma microbursts during combustion. These microbursts generate harmonic frequencies that interfere with the engine's resonance patterns, creating a feedback loop that prevents sustained operation. James moved closer to examine her calculations, his expression growing more serious as he recognized the sophistication of her mathematical work. These equations? Where did you learn thermodynamic analysis at this level? From the same textbooks your engineers use, Zara replied. The ones they donated to the public library when newer editions came out. From online courses offered by universities that make their lectures freely available. From 8 years of working nights at an auto repair shop where I got hands-on experience with every type of engine system ever built. Bradley was becoming increasingly agitated as he realized that Zara wasn't the unqualified diversity hire he had assumed her to be. Even if your theory is correct, which I seriously doubt, fixing harmonic interference would require completely rebuilding the engine's core architecture. We're talking about months of work and hundreds of thousands of dollars. Zara shook her head. Actually, fixing it requires understanding that the interference is being caused by a resonance mismatch between the combustion chamber frequency and the flywheel rotation speed. The solution isn't rebuilding anything. It's recalibrating the timing sequences to eliminate the harmonic conflict. Dr. Chun was now studying Zara's calculations with intense focus. Ms. Johnson, these mathematical models are extraordinarily sophisticated. Where did you complete your engineering degree? I didn't, Zara replied simply. I never had the money for college. Everything I know, I taught myself. The admission sent a ripple of shock through the laboratory. Bradley seized on it immediately. See? I told you this was a waste of time. She doesn't even have a degree. Patricia, we can't seriously be considering taking engineering advice from someone who's never set foot in a university classroom. But Dr. Chun was looking at Zara's work with the eye of someone who had spent 30 years in advanced engineering research. Ms. Johnson, these calculations suggest that you've identified a fundamental flaw in our approach that we've overlooked for a decade. If you're correct, the solution you're proposing should work in theory. It will work in practice too, Zara said confidently. But I'll need access to the engine's control systems to implement the timing recalibration. Bradley stepped between Zara and the massive engine that dominated the center of the laboratory. Absolutely not. This prototype is worth more than most people's houses. We're not going to let some amateur experiment on it based on theories she developed from reading our garbage. Actually, Dr. Chun said quietly, given our lack of progress over the past decade, perhaps it's time to try a different approach. Patricia, you can't be serious. I'm very serious, Bradley. Ms. Johnson's analysis identifies problems that our team hasn't even considered. Her mathematical models are more sophisticated than some of the work I've seen from PhD candidates. And most importantly, we're out of other options. Dr. Chun turned to address the entire laboratory team, which had gathered to witness the confrontation. Ladies and gentlemen, we've spent 10 years and $12 million trying to make this engine work using conventional approaches. Every strategy has failed. Every modification has led to new problems. At this point, we have nothing to lose by listening to someone who's approached the problem from a completely different perspective. We have our reputations to lose, Bradley muttered, but his objection lacked conviction. Our reputations are already suffering because we can't deliver a working engine, Dr. Chun replied firmly. Ms. Johnson, if we give you access to the control systems, how long would you need to implement your solution? Zara studied the engine carefully, her eyes moving systematically over components that the engineering team had rebuilt countless times. If I'm right about the harmonic interference, I can fix it in less than 2 hours. The timing recalibration is primarily a software adjustment, not a hardware modification. 2 hours. James looked skeptical. It takes us 2 hours just to boot up the diagnostic systems. That's because you're running comprehensive diagnostics on every component separately, Zara explained. I only need to access the timing control module and the harmonic frequency monitors. Dr. Chun made her decision. Ms. Johnson, you have 2 hours. If your solution works, we'll discuss next steps. If it doesn't work, we'll know that we need to pursue other options. Bradley threw up his hands in frustration. This is professional suicide. When this fails, and it will fail, corporate is going to want to know why we wasted time on amateur theories instead of focusing on real engineering solutions. Bradley, Dr. Chun said sternly, if you can't support this decision professionally, you're welcome to work on other projects for the rest of the day. Bradley stalked out of the laboratory, muttering about diversity experiments and political correctness gone wrong. But most of the other engineers remained to watch what would happen next. Zara approached the engine with the confidence of someone who had been visualizing this moment for years. She connected her laptop to the control systems and began accessing diagnostic data that most of the engineers had never bothered to examine. What are you looking for? James asked, his earlier skepticism now replaced by genuine curiosity. Harmonic frequency patterns during the failed ignition attempts, Zara replied, her fingers flying over the keyboard as she navigated through thousands of data files. Every time this engine has failed to start, it's generated specific frequency signatures that your diagnostic systems recorded but no one analyzed. She pulled up a series of waveform graphs that filled her laptop screen. Look at this. Every ignition attempt creates the same harmonic pattern. A frequency spike at 847 Hz that corresponds exactly to the flywheel's rotational frequency at optimal RPM. Dr. Chun leaned over Zara's shoulder to study the data. That's a perfect harmonic resonance. It would create destructive interference with the combustion cycle. Exactly. The engine is fighting itself every time it tries to start. The combustion system is generating energy at the same frequency that the mechanical systems are trying to absorb, creating a standing wave that prevents sustained operation. Zara continued working, adjusting timing parameters and frequency settings with the precision of someone who had spent years understanding how each modification would affect the overall system. The solution is to offset the ignition timing by 0.3 milliseconds and adjust the fuel injection pressure to shift the combustion frequency just enough to eliminate the harmonic conflict, she explained as she worked. James watched the modifications in amazement. Those are incredibly small adjustments. How did you determine such precise parameters? Mathematical modeling, Zara replied. I spent 3 years calculating the exact timing sequences that would eliminate the interference pattern without disrupting the engine's power output. After 90 minutes of careful adjustments, Zara stepped back from the control systems. The recalibration is complete. The engine should now be able to complete full operational cycles without harmonic interference. Dr. Chun looked at the diagnostic readouts which showed all systems within normal parameters. Ms. Johnson, are you ready to test your solution? Zara nodded, though for the first time since entering the laboratory, she looked nervous. Dr. Chun, before we start the engine, I want you to know that if this doesn't work, it's not because the theory is wrong. It's because I miscalculated something in the implementation. Let's find out, Dr. Chun said, moving to the engine's control panel. The laboratory fell completely silent as Dr. Chun initiated the startup sequence. For 10 years, this moment had ended in failure, Diagnostic errors, system conflicts, mechanical problems that forced immediate shutdown. The engine's initial systems came online normally. Fuel pumps activated. Cooling systems engaged. Electronic monitoring systems reported normal status across all parameters. Then came the moment that had never worked before, the transition from startup mode to operational mode. The engine's massive cylinders began their compression cycle. Fuel injection systems delivered precisely measured amounts of the hybrid fuel blend. Ignition systems fired in the newly calibrated sequence that Zara had programmed. And for the first time in 3,847 days, the Meridian prototype engine roared to life. The sound was unlike anything the engineers had ever heard. Not the rough, struggling noise of an engine fighting internal conflicts, but the smooth, powerful rumble of a perfectly balanced machine operating at peak efficiency. The laboratory erupted in cheers and applause as engineers who had spent years failing to solve this problem watched their diagnostic screens fill with perfect operational data. The engine wasn't just running, it was running better than their most optimistic projections had predicted. Dr. Chun stared at the readouts in amazement. Power output is 23% higher than our design specifications. Fuel efficiency is 31% better than projected. Emissions are 94% cleaner than required by environmental standards. James was almost shouting over the engine noise. It's not just working. It's working perfectly. Zara, how did you know the performance would improve this much? Zara smiled for the first time since entering the laboratory. Because I wasn't just trying to make it work. I was trying to make it work the way it was designed to work. The harmonic interference wasn't just preventing operation. It was preventing optimization. As the engine continued running flawlessly, the laboratory door burst open and Bradley Morrison rushed back in. His face a mixture of shock and disbelief. I heard it from 3 floors away, he said, staring at the diagnostic displays. The Meridian is actually running? It's been running for 12 minutes without any problems, Dr. Chun reported. Ms. Johnson's solution worked exactly as she predicted. Bradley looked at Zara with an expression that was part amazement and part humiliation. I don't understand. How did you solve in 2 hours what we couldn't solve in 10 years? Zara considered her answer carefully. Mr. Morrison, you and your team are brilliant engineers. You know more about advanced automotive systems than I'll probably ever learn. But you were trying to fix a problem that you had misdiagnosed. What do you mean? You thought the Meridian was broken. You kept replacing components and redesigning systems because you believed something was malfunctioning. But the engine was never broken, it was incomplete. The original design team created something revolutionary, but they never solved the harmonic equations that would allow it to function. Dr. Chun was studying the engine's performance data with growing excitement. Ms. Johnson, with these efficiency numbers, the Meridian isn't just a successful prototype. It's a breakthrough that could revolutionize the automotive industry. I know, Zara replied quietly. That's why I spent 10 years teaching myself to understand it. Over the following weeks, as news of the Meridian breakthrough spread through Apex Engineering and the broader automotive industry, Zara found herself at the center of a whirlwind of attention that she had never anticipated. Corporate executives who had never heard her name suddenly wanted meetings. Engineering journals requested interviews. Patent lawyers appeared with contracts and legal documents that promised to make her wealthy beyond her dreams. But the moment that meant the most to Zara came on a quiet Thursday evening when her father, William Johnson, arrived for his regular cleaning shift and found his daughter working late in the laboratory where she now had her own desk and her own computer. Zara, baby, he said, setting down his cleaning supplies and looking at the engine that had dominated so many of their dinner conversations over the years. I heard from the other folks that you got this old machine working. I did, Dad. William walked around the engine slowly, taking in the sight of diagnostic screens showing perfect operational status and performance data that exceeded every engineering expectation. You know, he said finally, All those years when I'd come home and tell you about the conversations I heard, about the problems they were having, I never imagined you were actually going to solve it. I couldn't have done it without you, Zara replied. You gave me access to information and insights that I never could have gotten anywhere else. You taught me that intelligence isn't about where you come from or what school you attended. It's about how hard you're willing to work to understand something. William smiled, pulling his daughter into a hug. Zara, I'm proud of you. Not because you fixed their engine, but because you never let anyone convince you that you weren't smart enough or good enough to try. Dr. Chan appeared in the laboratory doorway, having stayed late to work on the preliminary patent applications for Zara's solution. Mr. Johnson, she said, addressing Zara's father with the same respect she would show any colleague. I wanted you to know that your daughter has just solved one of the most complex engineering problems our industry has ever faced. Her work is going to change how we think about advanced engine design. She's always been special, William replied proudly. Even when she was little, she could fix things that other people couldn't understand. Mr. Johnson, Dr. Chun continued, I also wanted you to know that we've offered Zara a full-time position as senior research engineer, along with a signing bonus that should make it possible for both of you to live more comfortably. William looked at his daughter in amazement. Senior research engineer? Baby. That's what all those folks with the fancy degrees and expensive cars call themselves. Dad, Zara said gently, I'm going to be making more in 1 year than you've made in the last 10 years combined. And the first thing I'm going to do is make sure you never have to clean another office building unless you want to. But William shook his head. Zara, I'm proud of the work I do. Keeping this place clean and safe for brilliant people like you, that's important work too. I know it is, Dad, but now you'll have choices. 3 months later, Apex Engineering held a press conference to announce the successful completion of the Meridian project and the beginning of commercial production for the revolutionary engine system. Zara stood beside Dr. Chen and the company's CEO as they unveiled the technology that would soon power a new generation of ultra-efficient vehicles. Bradley Morrison, who had initially opposed Zara's involvement so vehemently, had become one of her strongest supporters after witnessing the depth of her technical knowledge during the patent development process. Zara, he said during the celebration following the press conference, I owe you an apology that goes far beyond what I said that first day. You don't owe me anything, Bradley. Yes, I do. I let my assumptions about your background blind me to your capabilities. I was so focused on your father's job and your lack of formal education that I completely missed the fact that you're one of the most gifted engineers I've ever encountered. Zara accepted his apology graciously, but her mind was already focused on the future. The success of the Meridian project had opened doors she had never imagined, but it had also given her a platform to address issues that mattered to her. Bradley, she said, I want to ask you something. How many other brilliant people do you think are out there, working jobs that don't reflect their capabilities because they never had access to traditional educational opportunities? Bradley considered the question seriously. Probably more than any of us realize. That's what I think too. And that's why I'm starting a foundation to identify and support non-traditional engineers, people who have the intelligence and passion to solve complex problems, but who need alternative pathways to develop their skills. 6 months after fixing the engine that had stumped Apex Engineering for a decade, Zara Johnson found herself testifying before a congressional committee about the importance of recognizing and developing talent, regardless of its source. The Meridian breakthrough didn't happen because I'm special, she told the assembled legislators. It happened because I had access to information, encouragement from my father, and eventually an opportunity to prove what I could do. There are thousands of people in this country with similar capabilities who will never get those same opportunities. But perhaps the most meaningful moment in Zara's transformation from janitor's daughter to respected engineer came during a quiet conversation with her father as they sat in the living room of the new house that her signing bonus had made possible. Dad, she said, Do you ever think about how different things might have been if you hadn't encouraged me to study those technical reports? William smiled. Zara, I think about how different things might have been if you hadn't been curious enough to want to understand them. Intelligence runs in our family, baby. It just took the right opportunity for yours to show. As Zara continued her work developing the next generation of automotive technology and supporting other non-traditional engineers through her foundation, she never forgot the lesson she had learned during that harsh conversation on her first day at Apex Engineering. People's assumptions about your capabilities don't define what you can accomplish. Your willingness to prove them wrong does. And sometimes the person everyone underestimates turns out to be exactly the person everyone needs. The engine that had been dead for 10 years wasn't the only thing that came back to life that day. So did the dreams of a young woman who had never stopped believing that intelligence and determination could overcome any obstacle, including the prejudices of people who thought they knew better. In the end, the most important thing Zara fixed wasn't the Meridian prototype. It was the dangerous assumption that brilliance only comes from expected places, with expected credentials from expected people. And that repair job turned out to be worth far more than any engine ever could be. If Zara's story moved you, imagine how many more stories are waiting to be heard, waiting to be told. Subscribe to our channel today because brilliance can come from anywhere, and we're just getting started. Thanks for watching. See you in the next one.